Hey everyone, so I'm really excited to put together this little video series. Let me close out this mono develop thing we have here. I'm really excited to put together this little series for Unit 6. Unit 6 can be difficult to jump back into because you've been on break and you kind of haven't played with Unity for a while, so it can be difficult. So I'm going to send out a video for each one of the little sections, and I'm going to break it up. I was trying to put it into one video and it just got too long. So I'm going to break it up into a series of videos. So what you'll be able to do is look just at the top, and if it's like, man, this is overwhelming, this is tough, my video will be there and you can follow the video and see if it helps you at all. So for this unit, let me say really quick before we jump into this, this is a very challenging course, and a lot of you figured that out first semester. First of all, you can still pass the second semester, so please get on it. But also, like, this is the course that if you need help, you need to reach out to me and let's get a one-on-one session. I will never turn you down for a one-on-one session. Let's get those scheduled, and I'll jump into class with you, and I'll walk you through every single step of the unit. So don't use that as an excuse not to get your stuff done. So I'm gonna put the OHS, what's in the OHS, and that's this right here, the same stuff you guys look at in the OHS on my right screen, so that you don't have to see it. And then I'm gonna try to step you through this kind of like I said, step by step. So I'm gonna start with 6.01, and I'm gonna open up my Unity project. Now this is where we should be so far. And if you're not here, this is when you need to be reaching out to me, okay? Because this is where we should be so far. You should be able to hit play on your screen, and then you should see the two objects interact with each other. And it may vary slightly based on what you wanted your physics to look like. Your ball may fall faster, or it may not even fall. It may roll to the left and hit something, or it may hit a plane. But either way, this is basically what it should look like. So what we're going to do today is I'm going to show you how to be able to have the user move this cube around. And we know that this is important, right? If you're doing any kind of game, you need to be able to control your objects, right? And you do that by using something called queries. Now, queries are anything that your game asks from the user, and then the user gives it back. That's a query, all right? You're like asking the user a question, right? And in this case, it's first of all, what key is he hitting, and then it's what is it going to do? What do I want my game to do when my user hits that key? So this is what we're doing today. Now, in Unity, this is much more complicated than most game development software, but and we have to use programming, but this is as hard as it gets. I will say this, like using controlling movement based off code is as hard as it gets when it comes to game design, in my opinion. So let's jump right in and let's just take a look. So the first thing you want to do, right? First thing you're going to want to do is go to File, Edit, Project Settings, Inputs. All right, and this is going to show us, and make sure you're not in play mode. That's what that tent's for. All right, and so the input manager basically shows us all the different things that are connected to different keys and different things on our keyboard. We can go in and assign things like here's our mouse Y. So this is very, very useful. Very useful to be able to see what keys and things are actually connected to parts of our objects. And you're going to use this a lot during this first unit. Or during the first unit of second semester. And then actually throughout the year, you'll always refer back to the input manager. So just remember to look at that. The next thing that you're going to want to do is open up MonoDevelop, or your MonoDevelop, which is your your programming software, right? Your text editor, by double clicking on your handler method. All right, it'll open up MonoDevelop just like this. And remember, this is where we have our basic thing where we actually translated. We moved our cube based on the using the transform.translate method. Well, we're just going to comment that out for now. We don't need that anymore. Okay, or you can just really get rid of it. You don't really need it. So let's hit Control Save. So now nothing should happen at the beginning of our game. All right, so we've gotten rid of that. The next thing, and like I said, I'm gonna go through the instructions. Now remember, I do not want you to copy and paste these pieces of code. It's very important that you're typing these, but that is totally up to you. That's kind of you taking control of your own learning. If you don't type them, I promise you, you will not remember them as well as other people do. All right, so the first thing we want to do is we are going to add this statement right here, this piece of code, to our update method. And I'm going to tell you what that's going to do. All right, so transform.translate. So we know what transform.translate does, right? Transform.translate changes the X, the Y, and the Z axis of our object that this is connected to, and this script, remember, is connected to our cube. And if you're, if you need, like I said, if you need to go back and look at previous units, this is connected to our cube. So this is saying, all right, instead of translating it to a point on the XYZ axis, we want you to look at the input, which is the keys, dot get axis horizontal. Okay, so instead setting the horizontal, right, which is that the Z axis or the Y axis, X axis, I don't know. But it's looking at the horizontal, the back and forth, and it's setting it equal to wherever that input, whatever that input says. So it's either right or left. So it's saying like you keep constantly updating and looking for whether or not we're pushing the right or the left key. Okay, that's basically what this is saying. And like I said, when you read in the OHS, these descriptions get very lengthy and it seems very complicated. And that's okay. I mean, they are complicated. But the only piece of advice I have for that is just to read them over and over and over again until it makes sense. And that's in programming, that's actually a pretty common practice, is read it till you get it. Okay, so if you don't understand a piece of code, read it from start to finish over and over, and eventually it'll start to make sense to you. I know it sounds very simple, kind of hyper simple, but I promise you it will work. So now the next thing we need to do is add this little piece of code. So we have transform.translate, which we already know how to run, and then we have input.getAxis for horizontal for our x value. Okay. Now, the next thing we want to do is we want to add this thing, we want to add something called times delta time. Now, this little piece of code, again, this is one of these that if you're looking in the OHS, it seems a little complicated, right? And the description's kind of lengthy, but what it basically is doing is it's multiplying the time that it's going to take for the next action by the time it took to do the previous action. So it seems complicated, but it's really not. What it's doing is it's making it to where no matter how much time each little frame movement takes, it will take about the same time for the second one. So it's kind of averaging out the time that it takes to move that object in between each frame. So it makes your objects move smoothly instead of like kind of jerky and bouncing around. Like it makes it move really smooth. So that's really all you need to know. Times time.delta time makes your objects move smoothly. All right, now the only problem here is we don't have a y and a z axis. Well, we have to have that. Remember, whenever you do parameters, when you give a function and you add parameters to a function, you have to have all of the parameters filled. Well, we know that the transform.translate right here takes the 0, the 1, the x, the y, and the z. Well, we need a y and a z, right? And for this case, we're just going to put 0f, okay? And we're going to put 0f. All right, so that's easy. So those are just like blanks. We're not putting anything in there for now. We're leaving those alone. F stands for float. All right, it doesn't, it stands for float. You don't really need to know that, but we're just leaving those as 0 float. Okay, so we're gonna save it. All right, and I'm gonna go down here. All right, and I hope I get a bug at some point here. I don't know if I'll get a bug. I really hope I do. Because like there is a section in here, I think it's called like bugs are part of it, or bugs are inevitable or something. So I hope I get a bug somewhere so I can show you guys like what I do to debug. If not, I'll make one and we'll do that. Okay. So all right, so right now we have what has happened now is that we've assigned our left value and our right value. Okay, so those are done. Let me save our script. All right, so Control S to save, and then this should update as well. And so you'll notice that once you click your handler again, now your code has updated in the inspector. So you can see to make sure that those changes have gone through. Okay. All right. So I want to just keep looking. One thing to make sure, and this should be, but it does remind you to do this really quick in the OHS. Click on your cube and make sure that you can see the handler script. All right. So make sure that this script is a part of your cube. If it's not, make sure you go to Add Component and add that handler to the cube. Okay. All right, now let's run the game and see what happens. So there we go. We have the same thing that happened, but now you'll notice that when I hit my right and my left keys, the cube's moving. All right, and so if you're a game designer, this is really cool. All right, this is exciting. So we're actually moving an object based off user input. And when I throw it right off the edge. Okay, so that's pretty cool. Just by one simple line of code, we can now control our cube. All right. All right, and then I think, yeah, it gives you a part in the where you can get the rest of it. Now, the next thing we want to do, and this is where like you'll start to kind of learn, the next thing we want to do is do the same thing. Input.getAxis horizontal dot time dot delta time. We want to do this exact same piece of code, okay? But we want to do it for our z-axis, right? Or up and down. Back and forth, right? So again, I'm gonna copy and paste. You are not. You're gonna type these out. All right, and I'm gonna replace right here the same piece of code for z. The only difference is instead of input.getAxis horizontal, I'm gonna do vertical. And these vertical and horizontal, these are like public variables that you don't really need to know. But input.getAxis vertical times time.delta, again, same piece of code, control save. I'm gonna go out here, I'm gonna run this, and now if it'll run, I can move forward and backwards as well. All right, so like I said, and we can move a combination of the two. And like I said, all this is doing is this little piece of code that we've created, all it's doing is watching the cube, and it's watching in every single frame. It's saying, hey, whatever the x is, whatever x is at that time, if the user is hitting the left arrow, right? Left arrow, I missed it. Then I want you to change the x by 1 each time that he's holding, as long as he's holding that button, so it creates movement. It's really cool. It's actually a really cool way to create movement. It gives us a lot of control over how the movement works. All right, now that's way too slow. Okay, so we need to speed this thing up. The way we do that is we create something called a public variable. Now, a public variable is something that can change. That's a variable. It's going to hold a value that can be accessed by anything in our program, not just our translate method, but it can be accessed by anything. And so we're going to create that. And one way we do that is we do public. All right, and public means, again, it's accessible by anything in our code. Float, okay, and float you don't really need to know about right now. Just know that's the type of value we're giving it. Speed, and that's the name of our variable, equals 5. Okay, and at the end of everything we put a semicolon. So public float speed equals 5. All right, so this is just saying, like, we have this variable, we're going to call it speed, and it's accessible by anything in my program. All right, and then once we do that, we're going to add this to our code here, so that we're saying, here we go, we're going to put speed times input.getAxis horizontal. So we're telling it how fast we want it to keep updating that. And remember, make sure, like, punctuation, spelling is very important here. Make sure they match. It should say speed, same capitalization. If not, it won't work. It picks up on things like that. Okay. So we're going to say now, instead of the default 1 for the speed value, we're going to put in 5, and it's going to multiply that, and it's going to do this 5 times faster than it did in its default. Okay, so that's basically what's going to happen. So let's hit save. Let's go out again. Let's run it again. It should be much faster now. There we go. Yeah. Oh yeah, much faster. And I can even like push the ball off the thing. There we go. I can go off with it. All right. So we've created some interactivity, right? So we could effectively, with all you've learned so far, and look, you can see the value is still going because the ball's falling. You could effectively build a game just off what we've done. Creating objects, giving them physics. That's what we did back in Unit 5, so go back and do that if you haven't gotten here yet. Created objects, giving them real-life rigid body physics. And then now we've learned how to actually apply user input to those. And remember, there's a lot of user input you can apply. You can do clicks, and you can add the up arrow could make the guy go up and down, or the space bar. There's a lot of stuff you can do by applying this same little piece of code. So the last thing we're going to do in this video is we're going to hold this. We're going to make it to where our cube can't leave our boundary, and that's probably something you want to do in a lot of your games. Maybe you don't. Right? If it's part of your game, if it's part of your concept in your game design document that you want the cube to be able to fall off the edge, that's good. Like, so for bowling, for example, if you're making a bowling game, it's a pretty good idea in this class. If you were making a bowling game, you would want it to be able to fall off the edge and fall into the gutters. However, if you're doing a putt-putt game, maybe you have boundaries and you don't want it to be able to fall off the edge. So I'm going to show you how to keep it within the bounds right now. And it's actually really, really easy. So we're going to open up the handler script again. So double click on your handler script and it'll open up MonoDevelop. All right. And the first thing we need to do is we need to add this new library. And the new library is, sorry, not a new library. It's a new public class called Bounds. All right. Now, this is something that you could create on your own. Now, remember, I'll show you kind of what a class is. It's a little bit complicated, but I'll try to explain it as best I can in just a second. All right, so here's the code, and this is in your OHS. System.serializable. All right, don't worry about that scary word. All right, it's not that big of a deal. Basically, serializable. I'm trying to think. How do I explain? Basically, it just allows the inspector to like look inside your class. That's what it's allowing. It's allowing the inspector. It's allowing your variables that you're going to be using to show up in your inspector, and I'll show you that in just a second. That's basically what serializable is saying. But public, remember, it means it's accessible by everything. Class is the type of variable, and in this case, it is a class variable. Bounds is just the name, so that's the name of our little public class. So a class is like a blueprint. A class is like us creating a very special variable that has all kinds of properties and methods and all kinds of stuff. And in a sense, our entire piece of code is a class, right? Public class handler. See, we see that? So it's a class in itself. And then we can create instances of that class that we can use in our program. Now, as we program throughout the year, this will become a little bit more clear, but for now, just know that a class is a very special type of variable that can hold a bunch of properties and a bunch of methods, okay? And in this case, it holds one variable, which is public, float, x minimum, x max, z min, and z max, okay? And what those are is these are going to be the bounds that we want to set our player to be able to move within, okay? So these are just 4 variables that we've created inside this public class that can be seen by our inspector. I'm going to show you exactly what that looks like in just a second. So now we need to create an instance of that class, okay? We need to say, okay, we have our class created, but now I need one of these classes to be used in my code. And we're going to put this just below our public float speed. All right, we're going to put public because we want to be able to access it inside the inspector. We want to be able to use it. We're going to put bounds. All right, bounds, which is the name of our class. And then we'll just write bounds again with a lowercase b. And hopefully this will show you guys, like I said, that punctuation matters. So now we have public bounds, which is the name of our class, and then bounds, which is a new name that we've given our new instance of this class. Now I could add another one. I could go down here and say like public bounds 2, right? And I could add 2 of these, and but we don't need those. We only need one set of parameters, but there may be a case where you need multiple boundaries in the game, and that's fine. Skee ball is a good example of that. It's got multiple boundaries, different little boundaries throughout the game. All right. So the last thing we're going to do is we're going to add this big piece of complicated code, okay? And remember, it's not 100% necessary that you understand every single step of this code, okay? But we're going to add this big piece of complicated code inside of our update method, and I'm going to try to explain it the best I can. And remember, you're going to type this out, right? So basically what this is doing, this little piece of code right here, I'm try to explain this the best I can without showing you guys what it looks like. Transform.position, okay? We know those. This is the transform. We've been using transform class. Position is a method of the transform class. Equals new vector3. Vector3 graphic is just a point in our game that contains that x, y, and that z. Okay, that's what that is. It's a point somewhere in our 3D world. So we are creating a new point that our game will pay attention to. All right. MathF is just a class that has a whole bunch of mathematic functions in it. You don't need to really know that. You just need to know it has a whole bunch of mathematic functions. Clamp is a function of the MathF library. all right, that clamp, all right, and then the parameters of it are X, Y, and Z, just like we had before. And so what we're saying is, for our X, Y, and Z, our transform position is our X. That's where our cube is on the X axis. Bounds.xmin, all right, bound.xmax. So basically what this is saying, what this piece of code right here is saying, is I want you to watch my figure. And when it hits that number on the x-axis, hits that number that I'm going to set for x minimum, I want you to stop it, clamp it, stop. All right? Keep those numbers from moving. That's what it's saying, okay? So remember, it's not important that you know exactly what all this code does, but you just need to know the general idea, which is that once it hits a certain point, it's going to stop it. I'm going to show you. So now we've created all this inside of our code, and I'm almost done, I promise. We've created all this inside of our code. And now I'm going to show you what doing this whole thing called public does. All right, and this is really cool. This is one of the things that really got me excited about Unity when I first started using it. So I'm going to go over here to my game, and I'm going to click on my cube. Okay. And now look at the handler script right here. Look at the handler script inside of our cube, inside of our inspector now. There is a speed value that we can change from here, which is so cool. This is what that public allows. It allows us to change the speed from here. Also, there's a new class. Yours will look like this, and if you click this arrow, it'll go down, where we can now set the parameters of our x minimum, our x maximum, our z, and our z max, which is really, really cool. So I'm going to set these to, I think it's like negative 4.4. I think it says it in your OHS. Let me make sure. So yeah, depending on how you create your plane, remember now these are something you'll change. The easiest way to do this is to grab your cube and move it to the edge, and then look up here to see what your z value is. It's about 4.4. All right, and then I go back and I look over here, and this is negative 4.4. So my z, let's do my z min would be negative 4.4, and my max would be 4.4. And 4.4, like, because I created a square. Now this is something you'll change based off your game. So someone sent me their copy of their game at the end of the semester. They have like a big putt-putt course, and it's really cool. So they would have all kinds of bounds, all kinds of boundaries, and you'll have to set those up, and you'll have to add those to your bounds method. If you need help with that, again, that's what a private session is for. All right, so let's start the game. And now you'll see that I can move. My ball can be pushed over the edge, but this cannot. Okay, and you'll notice that if we added this component, if we added this handler to our ball, we could also the ball would also be held within the boundaries of the plane as well. Okay. All right, so I know this was a lot. I know there's a lot of stuff, but I hope this one got you really excited. So the next one I'm going to do is the projectiles one. I believe it is called 6.02, so I'm going to run through that one again. I'll send that out in a separate video so you can do these one at a time. Remember, if you need help on any of this, your first line of defense is to watch the video again. Second is to go through the OHS. And remember, follow it step by step. Never skip a step. Most of the problems we've had in this course are people skipping steps. Don't do that. And then obviously your final line is just to send me an email and say, hey, let's get in the private room and let's work through this together. And I'll work through it one-on-one with you as long as it takes. Okay? So good luck on Unit 6, and I'll see you in the next video. Bye.